Hello everyone, and welcome to another lovely lesson of Math 4. Today we're talking about end behavior. So we're still really focusing on the different characteristics of graphs. That's what our first unit is on, being able to analyze and interpret graphs properly. So we're talking about end behavior, and we have been, for the most part, right, been focusing on different parts. We're talking about how to determine intervals, how to state them, and then also how to figure out the domain and range, where domain is the x part of a function, and range is the y, the up and down part of the function. So building off this, we will be using some of these symbols, but we won't be using notation in the way that we are talking about domain and range for end behavior. So you're probably thinking, what is end behavior? And what end behavior is it's effectively what's happening as the function leaves the graph. So we have to determine what's going on when we go to the right, and what's going on when we go to the left. So let's focus this time just on this graph's left part. Try to describe what's happening as this graph goes left. Well, as it goes left, isn't it going downwards? You guys see that? It's going downwards, right? It's pretty much going diagonally. So if this is all really needed, we'd be done. The end behavior is, as the function goes left, it goes downwards. But there is a mathematical way to write this, and that's the way that you need to learn today. So if it goes left, guys, remember range of domain. Which one controls us going left, x or y? It's the x, right? So as x is going to the left, as x is going to negative infinity, it's going ever always to the negatives, it goes downwards. What controls the functions downwards? Isn't that the y-axis? So, and it's going downwards, so that means y approaches negative infinity. So to put it together, we would have as x approaches negative infinity, y approaches negative infinity. Don't let this confuse you. This means exactly what we just wrote. As the function goes left, it goes downwards. As x goes to negative infinity, y goes to negative infinity. That's what that means. Just think about what the negative infinity direction for y, negative infinity direction for x means. Obviously, positive for x means go to the right, and positive for y means going up. If I wanted to get super fancy, I could replace the y with f of x. Remember, f of x and y are the same, but if you prefer, you could just leave it as y, and that's fine. I just want you guys to know that f of x and y are the same thing. So that's the left side, but doesn't this have two ends, the left side and the right side? So let's go ahead, get rid of all this, move this over here, and describe what the graph is doing as it goes right, or the function as it goes right. We notice that it's going in this upwards direction, right? So as it goes right, it goes up. So as the function goes right, it goes upwards. And now we're trying to represent it with symbols, just like we did before. As the function goes right, well, that's going to be x. X is going right. So as x goes to positive infinity, that's to the right direction. See, positive 2, positive 4, 6, 8, 10. It's going upwards. Well, it's the y part now that's going upwards, right? So y goes to positive infinity. So the answer is, as x goes to positive infinity, y goes to positive infinity. Once again, I can replace y with f(x) if I want to, but that's not necessary, just so you know what's going on. So that wasn't too bad. Why don't we go over one more graph that is a little bit less obvious, perhaps. So right here we have an exponential function. And if you're going to find the end behaviors of this, well, let's just take a look at the end behaviors. On the right, we can see that it's going upwards, very similar to the last one. But on the left, notice how it's kind of just flattening, right? It's flattening on this zero line right here. So let's deal with the right side first. That one should be a bit more obvious, right? So it's going upwards as we go to the right. So as x approaches positive infinity, y approaches positive infinity, it's just like the last one. However, are we going to say y is approaching negative infinity for this one? It's not, right? In fact, notice how it gets really, really close to a certain number. What number is that? It's getting close to 0. So it's saying, instead of saying as x approaches negative infinity, y approaches negative infinity, this is going to be as x approaches negative infinity, y approaches 0. So whatever flat lines is called an asymptote right here, to a certain part, a certain number, instead of just going straight downwards, we could say that's actually approaching a certain number. It'll never reach this number, just like how these will never reach positive infinity, because you can't reach positive infinity, but we know that it will always go in that direction. And that's what end behavior means. It just means describe what the end directions are. And that's it for this lesson. If you have any questions, stop by during office hours. Otherwise, I'll see you guys in class. Bye.